Good morning, everybody. I also want to give credit to a colleague of mine, Gerhard Rolzhagen. Basically, the two of us share this task of coordinating our what we call the Near Earth Object segment within the European Space Agency. And the title page, I put a picture of a comet. So why do I put the comet if I say who do you call when an asteroid is coming? Because that's a very good test case. It's comet sighting springs. This is an image I took in January with a 1-meter telescope. Look at the presentation later if you want to see it in better quality. It doesn't really show up very well here. This comet is not a near-Earth object, but it's a near-Mars object, and it will fly by at Mars at a distance of 120,000 kilometers in October this year. And 120,000 kilometers, just visualize that. That's about the third the distance between the Earth of the Moon. So imagine a possibly 10-kilometer object, which is what this could be. We don't really know. It could be anywhere between a kilometer and 10 kilometers. At that distance, you could actually resolve it with a pair of binoculars if it were at that distance to the Earth. And obviously the spacecraft operators are quite worried about that. So on our side in Europe we have Mars Express at Mars, and we have regular teleconferences with the people to see how they react. And they will mitigate risk to the spacecraft by changing the orbit such that you, so to say, hide behind Mars and things like that. So it's a really good test case. So I think I keep getting these questions, why don't you worry also about comets? Well, in essence, yes, we do. Right now, we don't have all the mathematical tools in place to treat with them, or treat them the same as we do asteroids, but it's the same issue. So the question is, whom do you call when you see an asteroid coming? The answer, I can preempt the whole talk already, is right now, call me. But I will show you that we are under preparation, or we are preparing a good answer, a better answer in a very international scene. So let's make a little test case. Here is a typical image of an asteroid. So this little dot, which is not moving because the telescope was tracked following the asteroid. This is from an amateur colleague of mine. Yesterday we had a question in the evening lecture, how important are amateurs? I think most of the follow-up observations of asteroids are done, or a lot of them are done by amateur astronomers. So this is what we really see. And the first part of this process, whom you call when you see an asteroid coming too close, of course, is really the important thing if it has a chance to hit. The first part is well established. This is the scientific part, or the mathematical part, if you will. So up here is this asteroid. You observe it with this telescope. I just love these telescopes that point out of the dome, so I did this little drawing yesterday. Everybody who observes asteroids seriously and performs position measurements submits their observation to the Minor Planet Center in the US. So all the position data is collected there. So we go to the Minor Planet Center, and the Minor Planet Center does a preliminary orbit computation. If this object turns out to be most likely a near-Earth object, the Minor Planet Center will give a designation to the object and will flag it as an unknown. They only do a sort of a preliminary orbit analysis, and we have two systems on this planet. One is operated by JPL in the US called Sentry. The other one is currently at the University of Pisa, the NEODICE system. And some of you I saw in the CDs worked with Professor Milani. When I googled for an image of Andrea Milani, this is what I got. So, can't see his face, so that must be him really. And NEODICE is also currently being integrated into our European SSA NEO system. That's why I have a screenshot here. Now these two systems basically do, independent from each other, the same. They do a detailed orbit computation, a much more accurate orbit computation, and they propagate the orbit about 100 years into the future. Then we had some talks in the morning about virtual impactors. There's lots of mathematical techniques where some of you are the experts. What they come up with is some kind of impact probability. If you have really sharp eyes, then you're all astronomers, so you should have. You can read that this says impact probability. And here even I can't read it anymore, but trust me, also there somewhere in the table we have the impact probability. If that number is larger than 0, if in the next 100 years, typically we do longer propagations for certain objects, if that number is larger than 0, we put the object on a so-called risk list. So that's a list with all the objects we call threatening objects, and they have a chance to hit yours. So those are the ones that we should really worry about. Not really worry, but those where we want to spend some money on to avoid being worried, right? So that's simple. That's done, and then there's a little arrow here. If the risk of the object is larger than a certain value, then none of these systems is simply allowed to automatically post the result. They first have to check, they have to cross-check and make sure that they get the same numbers. They're not identical because they are independent software systems. But you know, if one object has a chance of say 10% to hit, if one system says that, and the other one says the chance is 1 in a million, then somewhere there must be a problem. Now, typically nowadays the systems agree very well because there has been lots of iteration. The people talk to each other, they know each other. That part is easy. So we now know when an object is coming. We know what the probability is that it hits, at least to a certain accuracy. So simple. Still we don't know, well, what happens if on this list now, tomorrow or today in the afternoon, there were an object appearing which says it's a Apophis, it's a 270-meter object. Well, we made a mistake and although we have new observational data, there is suddenly now a 30% chance of Apophis hitting the Earth in the flyby 2029. What do we do? This is something that's not covered here. This is just the scientific part. This is a photo of the red telephone that some American president used to call Russian presidents, or was it vice versa? This is not what we are doing and what we will be doing. We have had discussions over, I think, really well, constructive discussions since 2008 in the frame of the United Nations Committee for Peaceful Uses of Outer Space. That's a committee where I think about 75 countries on this planet are a member, typically those that are interested in space, and that's the international forum where topics like the near-Earth objects are discussed. And there was something in the year 2001 already, the so-called Action Team 14, which is just one of many action teams, but that's the one that deals with this topic of near-Earth objects. And from 2001 to 2008, basically what they did is they found out what is the status quo, who is doing which things, and then starting in 2008, they had the mandate to come up with a proposal on what should we do if really there were a serious threat by an asteroid. And this is the result. The result was agreed and accepted by the General Assembly last year in December. So this was presented in February last year to the Scientific and Technical Subcommittee of COPUS. In June it was agreed by COPUS itself, and then it went to the General Assembly in summer, and they published their final report in December. And this is basically work that started more or less in 2001. So it takes a long time to get things done in the UN, but the good news is that once it's in place, you hopefully then have the mechanism to react quite quickly. So here's the plan. The plan, or it's already started happening. We want two groups. One is called IAWN, and the other one is pronounced SMPAG. This was coined by colleague Lindley Johnson from NASA. I kept mumbling SMPAG, and he just looked at me and said, I just call it SMPAG. So this is good because the idea of this group is to bring all space agencies on the same page. That's why it's a nice name. So let me start with this one. The IAWN stands for International Asteroid Warning Network. And that has been existing since many years. And you are part of it. You may not know it, but most of you are part of it. The IAWN is a network of observers, people that observe asteroids, of modelers that find out what's the effect, where's the shock wave, and how many windows can you damage with a 15-meter object as opposed to a 19-meter object. It incorporates the people that do the orbit propagation. All this is basically, of course, already there. And to make it a bit more formal, we established a steering group for this, or a steering committee. I forgot what the real name is. We established a steering group for the IAWN, and I think, Giovanni, you are part of that. I think, Alan, you are part of the steering group. I'm myself in there. I don't know. Anybody else in the IAWN steering group? You know? No. Okay. Well, but anyway, so some of the people in the steering group are in this room. So if you want to learn more, talk to Alan or Giovanni or myself. This is number one. What they do is what I just described before. The easy part is maybe a wrong term. I don't want to downplay the importance of that work or how complicated it is. But this is basically already in place. We can predict an impact time. We can predict impact locations. We have a bit an idea of the severity. I think there is still a lot of work that needs to be done. I mean, if I have a 20-meter object and I don't know whether it's a piece of iron or a piece of rock, then it's very difficult, of course, to find out what really the effect will be if it hits. But anyway, I mean, this is more or less in place. This other group here, the same page, is called Space Missions Planning Advisory Group. And space missions means, in particular, missions to deflect asteroids. And like the IAWN mission that we discussed before quickly, or there are other studies going on. So what can space agencies do to help us mitigate the issue of an annual threat? So the same page, here the steering group was formed in January this year. For the same page, we had the first official meeting in February this year at ESOC in Darmstadt in Germany. And currently ESA, the European Space Agency, is chairing this group. We are the chair of the same page. The next meeting will be in June this year in Vienna, where we exchange information, where we simply tell each other, well, what have we been doing so far? Yeah. And an important contribution could come from NeoShield. Alan is coordinating the NeoShield project, where there are lots of studies done addressing what we know, how we could mitigate the asteroid threat. So that's what we do in this group. Now, the groups have been formed. We have a steering committee for the IAWN. We had the first meeting of the same page. They still really haven't done anything yet. But I mean, I think last year I read in a newspaper article something, I think Hans Wickmann was saying, well, if really there were an asteroid threatening us, we are not prepared. This is only half true. I mean, now we at least we know what we should be doing. Yeah. So this is the first step. We have the mechanism in place. Now we have to get started doing some real work. And I just want to now focus a bit on the second part, the maybe more difficult part, because it's not yet there. This is, okay, suppose I have the asteroid threat, and here's where the IAWN comes in, what I said before on the previous view graph, how do you compute the orbits, these kind of things. You need to observe the objects first. And then there must be a decision, which I simply called, is it large? And what I mean with that is, after or above a certain threat, say a size of an object, or the kinetic energy, or I don't know yet what, that's when the only thing you can do is you really want to deflect it. If it's something like Chelyabinsk, we don't need to send a spacecraft up. We just tell the people to stay away from windows. That's all. So we don't need to get the space agencies really active. So that's when I call it a not large object. And then you just have to activate civil response. And this is something which, as per the statues is part of the IAWN again. They deal, or are supposed to deal with, interfaces to emergency response agencies or entities. In ESA we have started doing that. I'll come to that in a few graphs later. This part here, how would you do a deflection mission? That's what needs to be discussed in the same page group, where we will come up with well, mission scenarios. We have a lot already. As I mentioned, NeoShield has done a lot of work. Other groups before, Don Quixote we heard before, ESA study, well, a study by European industry funded by ESA. And but we need to be doing more here. We also need to really work out how would you organize such a mission. Suppose there's a threat and something goes over Costa Rica. Does ESA care? Should we care? Probably we should. But how do you set this up? Is this something where we say, well, Costa Rica is really close to the US, so they will probably handle this? Or maybe not. So that's exactly the kind of things we will be discussing in this group. And this is why I still can't really tell you who to call, because there are a few open things that these groups and these groups first have to discuss and find out. But at least we have a forum already in place now where it can be discussed. And that's what I already see as a major achievement. Right, so just for your reference, the IAWN, this meeting I mentioned in January was hosted at the Minor Planet Center in the US. And they now also host a web page. If you go to the Minor Planet Center's web page and simply add /IAWN, or you click, there's a menu point in the top. So go there and have a look. There's documentation there. There's some text explaining what the group is about, who's in the steering committee and things like that. The same page, we are actually maintaining a web page at ESA, so there you go to Cosmos ESA INT, same page, and then you end up here. And for the members, you can log in, and then you have more information, but there's also everything we can make publicly available, like the presentations from the meetings, you will find here. So this is some homework to look for yourself. I want to focus now a bit on what we are doing within the European Space Agency. You will have a keynote tomorrow by Alan, where Alan will address the other major activity in Europe, namely the EC-funded NeoShield project. So we are luckily very complementary to each other. So I will not go into that very much. I'll leave that up to Alan for tomorrow. So this is really now ESA-centric, and of course there are many other activities, mainly in the US, but also now, countries like Korea are setting up telescope networks. So I'm just focusing on what we're doing in ESA because that's what I know about. So 4 things related to the IAWN: observations, orbit computations, modeling of impact effects, and interfaces to emergency response agencies or entities. I never know what word to use. So let's look at each of these in 1 or 2 slides. The first thing I should say, we have inaugurated in May last year, 22nd of May, a so-called Near-Earth Object Coordination Center. And those of you who were in the public talk yesterday, Ettore gave the public talk. He's sitting there in the back. He is managing this coordination center for ESA with his, in his role as representative of the company Dymas. And it's located in Frascati. Here is Rome. And those of you familiar with observatories and observatory codes, each observatory that contributes asteroid observations or has ever contributed has a number. This is 036 right here. That's the Vatican Observatory, which is less than 15 kilometers away. So we're really in godly hands there. It's quite good. And you also see the building is like a bunker which is built half into the hill, so it's really impact proof. Mainly what we do there is we host servers to do computations. I mean, everything is distributed. We don't have a telescope there. So but it is important to have a focal points, to have a place where you can point to and say, okay, this is where all the information comes together. Well, that's where it is. And if you want to know more there, you talk to Ettore because he knows everything about it. Observations. Well, the first thing is there are all these big surveys that scan the sky, and they're all funded by the US, mainly NASA, but there's also military funding in there. In Europe, we are currently trying to catch up a bit. We have a telescope development in place where we develop a really wide field telescope with 1 meter effective aperture, and then it has 7 by 7 degrees field of view, which is like 50 times larger than what I get with this telescope. So cover a much larger field in the sky, but that's still science fiction. You have the funding to build a prototype, and in 5 years I may say, yes, now we have the prototype, but for now all we have is this telescope. It's a 1 meter telescope on Tenerife, which we use 4 nights per month for mainly doing follow-up observations of asteroids. Okay, well, if the space debris people don't use it, then I get to use it more. So in May I have it, the next lunar period we have it for 8 nights, and then in June 8 nights. So that's one of the things we do, and this is an interesting object here, this little streak. This is now really an asteroid, or actually it was an asteroid, or it was 2 asteroids. It's the remnant of an asteroid collision, where we also observed this with the OSIRIS camera on Rosetta, and because of the totally different position in the solar system, we get a very good 3D view, and we could really show that this cannot be a comet, that this was the result of 2 asteroids colliding in space about a year before was it 3 weeks before we did the observation. So we're using this telescope a number of nights and contribute a tiny little bit, but admittedly not very much, to the survey of the sky, but mainly we perform these follow-up observations. The other thing we do, we have an agreement with the European Southern Observatory. So very often you'll have a small object which comes close by the Earth. It's discovered, but then by the time you want to follow it up, you want to confirm the orbit, it's already so far away that it's too faint to be seen in a 1 meter, 2 meter size telescope, and that's typically what asteroid people have. So we came up with an agreement with the European Southern Observatory, and we now regularly use the VOT, the Very Large Telescope, which is an 8 meter telescope for follow-up observations, and we focus on these objects which are on the risk list. So if we have an object on the risk list and we know we could see it with the 8 meter telescope, then we get the time to point there. And we managed so far, since we started this, which was about 6 months ago, to remove 3 objects from the risk list completely. They're just gone. They're not on that list anymore because we have better orbit data which let us retire the impact risk to 0. And there's a couple of examples here. This is the kind of images we get. And here you actually have to search for it. There's an object. That's not the NEO. That's a main belt object. And there is somewhere really faint. Now I can't see it myself, actually. Well, that's why we need the big telescope. But there's 3 asteroids in here, and one of them is the NEO. So if anybody's interested, oh yeah, I can see it on the monitor here. It's easier here. So that's the kind of stuff we do in terms of observations. Orbit computations, I mentioned the Neodice system before. Other people have mentioned it. Now here I really have a picture of Andrea Milani. That's him next to my telescope in my backyard. So he was so shocked that he looked a bit strange, but that's the only picture I have. So, and of course, this is a very elaborate system which was built up by many Italian scientists, and I think some of them are in the room here. And this orbit prediction is really, well, mathematically very complex. We had some talks in the morning, so I think Europe really has a very good expertise in that field, well, in particular in this area in Italy. So that's very important. So what we are doing is we have a website, and I think I never put anywhere what our URL from our website is. So if you go to ileo.ssa.pisa.int, that's the website of our coordination center. And from there, you have this menu on the left, and the second menu point is called risk page. That's this page which lists the objects which have a chance to hit our planet. But there are other things. For example, Giovanni in the back there and a team around him built up something called a priority list many years ago. And that's a list of objects which need more observations. And if you don't observe them, then they get lost at some point because the orbital uncertainty is too large so that you cannot recover it. And that's a very important thing, which is also currently integrated into the system here. And we still have, of course, the old system is still running, but we have a duplicate system here. So we're slowly moving together the European assets and trying to provide a single entry point to all these different assets. Another one which has been existing since a long time is ESRIN. It's the physical properties database of asteroids or of near-Earth objects built up at DLR Berlin, the place where Alan is from. It was done by a colleague of Alan, Gerhard Hahn. And also that database is being integrated here. Now, we don't just bring things together, we try to provide some added value. For example, this database, this physical property database, initially is an ASCII file and was maintained as an ASCII file. What we do now, we have it in a real SQL database, and you can have search functions, and you can just enter, give me all objects with a negative inclination, and bang, then you see immediately that there are 3 right now, and it's quite convenient. It's really nice. So that's what we're doing in that field. And impact effects, I mentioned this before. This was taken after the Planetary Defense Conference last year in April. We were in Frascati, and as part of the conference, we were all brought to the crater and could see this meteor crater in Arizona. That was presumably a 50-meter object which came under some angle, and all the experts were there, and some people said it came from the left and others came from the right. It's hard to say, apparently, but what we can estimate reasonably well is the size or the mass of the object. It was an iron object. It was about 50 meters in diameter, and the crater now is 1.5 kilometers in size. Now, a similar sized object, well, a bit smaller, 30 to 40 meters, exploded over Tunguska in 1908. And it didn't even reach the ground. So this is what I said before. To really estimate the effect that an object has is tricky, mainly because in many cases we don't know the physical properties of the object. So we need to do more. We need to do better observations. We need to do physical observations. We need to do spectroscopy of asteroids. That's hopefully coming soon. I mean, there's a next round for European Commission proposals in the pipeline, and they had a call in particular also to address this question: how do we better characterize physical properties of asteroids? I hope that some of the proposals that came in will address that, because right now, definitely on our side, on ESA's side, we're really not doing enough in that field. There's not many groups that do observations which would let us, it is difficult, and admittedly, which would tell us, is this an iron object or a piece of rock? But this is the range of effects that you get, and this is something we always have to face with. So the impact effects, we didn't do a lot of work there within ESA, but one thing which I think was quite good, we had a contract last year where the final highlight was that we got together some experts in the field for 2 days in Spain, in Tres Cantos, close to Madrid, and we derived a roadmap. Now, roadmaps are always nice. Everybody does that. Well, now we did it too. And we have 2 roadmaps now, one which tells ESA, and this is particularly for ESA, what could we be doing in the future to better support the understanding of the modeling of impact effects. And the second roadmap is addressing mitigation missions, space missions, asteroid deflection missions. Here, these roadmaps are public. I can point you to a link somewhere if you're interested. But the main conclusion for these impact effects roadmap was we realized that there is a lot of expertise, again, already out there. There are all these scientists that model, if I have a 30-meter object with that velocity under that angle, then this is what happens. And they publish a paper about that. And then there's another guy who says, if I have a 26-meter object and it's under the other angle, and then they publish another paper about that. What's really missing is it's some kind of an engineering tool, and that's something we would need in the agency. If I have a predicted object coming in, I want to press 2 buttons, and then in half a minute it should give me a rough answer of what really happens. And there is something that goes in that direction. That's this Impact Earth tool, which was developed. Where was it developed? Not here, but some. Yeah. Yeah. Okay. Good. Yeah, I forgot. Yeah, but it was somewhere in this part of the world. So. That's going in that direction, and we looked at that too, but what we really think we should do is the scientists should come up with a set of reference cases, and then you plug an engineering tool on top which interpolates between. So then if I have any given case, then I at least get a rough idea of what the effects are. But that's, again, that's for the future, but at least we know what we should be doing and where it would be worth spending some money if you only had the money. So that's already an important thing. Interface to emergency response entities. That's something where we started working on in ESA last year in September. We had a workshop in Darmstadt again. For some reason we like doing these things in Darmstadt. That's simply because it's very central in Europe, and even there's always flights. Did I learn even from Boulder, I think, to Frankfurt, so it's easy to reach, so that's good. And we had invited the representatives of emergency response agencies of countries which are ESA member states. This is because we're ESA, so we talk to the people that give us money, and that's the member states, okay? So we had 6 countries showing up. And it's interesting. I mean, there in the US, it's quite clear, I think, at least seeing it from the outside. They have something called FEMA, the Federation Emergency something. I forgot. What does it stand for? Do you know? Federal Emergency Management Agency. Yeah. Here in Europe, it seems to be more tricky. So I know I was in Switzerland. That's the Lake Zurich here. And down there, they have something called Bundesamt für Bevölkerungsschutz, and they have a Nationale Alarmzentrale, a national central something. And I have a name of a person and the telephone number whom I should call if somebody tells me there's an asteroid coming and exploding over Zurich. So with Switzerland, we are fine. It's settled, it's gone. We have all the interfaces in place. In Germany, there were 3 different agencies or entities coming only from Germany to this workshop in September. And I asked them, so what are you doing? And they told me something. And the other group, they do something else. And I said, how do you know that this guy is not doing it? Yeah, well, we just know. So it can be quite difficult to set this up. But in essence, this is exactly what we are now doing. We are really getting in touch with all these people. I go to conferences. I mean, they have meetings like we have where, the disaster management people meet and talk to each other. And now I show up and tell them about asteroids, and in the beginning they laugh, and then they say, hey, that's fun, we want to talk to you. So that's good. They're really very motivated. It's nothing new, because the effects that we get, like in Chelyabinsk, it's a shockwave. Well, guess what these guys just did before I came there? They had an exercise in their city where they modeled, or where they simulated the explosion of a truck with chemicals on it, and the main thing was it generated a big shockwave. So for them, if you just tell them, look, this is the event, and you should expect a shockwave with that and that much overpressure, they know exactly what to do. It's nothing new for them. Tsunami, no problem. I mean, not in Switzerland. They're not so worried about tsunamis there. But in the Netherlands, for example, I would guess that if you tell them there is a wave coming which is 30 meters high, then I immediately, actually now that I say it, I also know a name of a person who would immediately know what to do. because, you know, they're prepared for these things. There's nothing different. So the only thing we need to do, and this is what we now do as the SSA program in the European Space Agency, we build up the interfaces to talk to these people. And then if Milani or Steve Chesley or whoever or Don Roman see on their web page we have an object, they call somebody in ESA, indeed probably me and Gerhard, and then we know whom we have to inform, and we will go via our international relations people. Once these interfaces are set up, this goes within 5 minutes. That's the good news. We tested that a while ago, for example, for satellite reentries. I mean, this is a very similar issue. Satellite reentries, these people know about. They know exactly what it is. They know that there's a chance of 1 over 10,000 that, say, Rosat falls down over Switzerland, but they were prepared for that. They said, okay, look, I mean, you know, we were ready, and had you said, okay, now the chance is 1 over 10 that it happens over Zurich, we would have had a message ready to be read out in the radio, in the news. So they know exactly what to do. It's just us who don't know. And well, in another year, I think this will be all settled, and then it's all in place. We are continuing to work on that. We'll have another one of these emergency workshops where we invite people. So if you know anybody who should go there, then let me know. Because last time the response was not as high as we were hoping. It was 6 countries out of 18 that pay for SSA, but you know, you always have to get stuff started. Concerning the same page, so this is really what we should be doing, isn't it? As a space agency, we should be focusing on this. Interestingly enough, we focus more on the other stuff. And here I see people like you will hear tomorrow, again, the NeoShield project. You actually do more space-based work than we do in the agency for this particular problem. But that's good, because that's what I said before. We are very complementary here. But we did support from the very beginning the development of the same page. There were a number of preparatory workshops where really the Action Team 14, this Action Team mandated by the UN, they called for preparational meetings where we invited people that defined, for example, drafted terms of reference, describing what this group should be really doing. And we started in 2010. This was, I think, in October 2010. There's me looking at the sky, all scared, hoping there's something coming at me. And this is a screenshot from the meeting that we had in February. And I think that's you, right? It looks like Alan has the same shirt here. Yeah. So this is from a Euronews report. So also the TV people are very interested in this topic. It's obviously a very sexy topic and nice to report, and we can do great animations. So we are involved in that. The current members of the same page are these. Most countries, the members are the space agencies or space offices, but the membership for this is a bit tricky, and that's also one of the discussion points we're still having in the terms of reference. How do you define who is a member and who nominates somebody to become a member? And there are countries where it's clear. Apparently NASA can be nominated by the State Department, or was it the other way around? But in other countries it's not clear. They, so to say, nominate themselves. And so sometimes you see a space agency here, and sometimes you just see nothing. About maybe they don't have a space agency, but they were still quite keen on being there. And this list, of course, is growing. I mean, the more meetings we do, the more people hear about it, the more they will join. And in the end, the idea is to really have every spacefaring capability somehow combined in this group. And then we meet once per year, hopefully linked to some other meeting, like the next one in June will be in Vienna, where most of these political people will go anyway, because that's when the COPUOS sessions happen in June in Vienna. So we'll just do the 2 days before everybody is there anyway. We'll do the same page meeting, and hopefully that maximizes the number of participants. So in this particular group, we need to agree on the final terms of reference, and then I mentioned this before, it's mainly an information exchange thing. You will invite the people to give presentations on the studies they've been doing, on the work they've been doing. I mean, the Deep Impact mission, for example, is something which is a real demonstration that you can actually hit a small body in the solar system. You have done it before. It has happened already. One of the things which you may remember in the very beginning where I was very vague, and you have this flowchart thing and it says object is large. What does it mean, large? Is it 100 meters? Is it 50 meters? Do you really want to take the mass or the kinetic energy rather than the size? That's exactly one of the mandates of the SMPAG. These guys are supposed to discuss this, of course, drawing on expertise from the scientific community. But in the end, that's where we want to sort this out. Because in the end, if you need to launch a space mission, it costs a lot of money. And somebody has to pay for that. So that's where we think it makes sense to at least have a discussion on the decision criteria. And I don't see these people really having all the answers. They need a lot of support from ongoing studies. But that's one of the points we'll be doing here. Right, this one I mentioned before, that's the roadmap on impact effects. Somehow the slides were a bit mixed up there. I did mention also that a lot of work is done within the NeoShield project, so more about that tomorrow. We had addressed briefly the Don Quixote mission study and AIDA. So of course, being a space agency, we do study space missions, and there's just, I think Wednesday, what's Wednesday, it's not today, just today, and I'll miss it, gee, we start a new internal phase of this study where we look at some technical details which were identified as open issues in the previous round, and I missed the kickoff, so, you know, we should be honored. No, I'm not rather I'm here, to be honest. It's nice to be here. I'm honored that I can be here. So this is something which is ongoing. Also, as I mentioned before, it's a study. It's funded by the General Studies Program in ESA. If you want to make this fly, then you need to move the project into a department or into a directorate where you can actually build a mission that flies. And one of the options would be the Space Situational Awareness Program. That's where we can go to the next ministerial conference to our political delegates and tell them, look, we need 100 million. They did a fantastic study. It's feasible. We can do it. It's something we do together with the Americans. So the idea here is to impact the smaller object of the binary, and the impactor would be done in the US. They have the expertise based on the impact, and we would be doing an orbiter that characterizes the system before and after. So in the next round of where we tell people what we want to do, we could go and could say, look, we need that and that kind of money, and we want to do this and that. If all the minister representatives tell us that's a fantastic thing, we want you to spend all that money, and they give us the money, then we can do it. This is how such missions work. So the fact that Don Quixote was not flying doesn't mean it was cancelled. It was a study, and when the study is done, then that's it. Then we need to actively do something to continue. So I wanted to clarify that a bit so that you don't say, well, Detlef said they will do this mission, and now I never see it flying. That can happen again. It could be that we, if people say we don't have enough money, then that may not be in the next round, but then hopefully a few years later. But at some point we'll get a demonstration mission, I'm sure, because it's a technological challenge for European industry, which is on the right level of complexity. What I see is that industry wants to build things which are new, because that's interesting, but not too new, because then there's a risk that it doesn't work, and then then they fail and they don't like that. And I think something like showing that we can hit a small object. We did so many studies and papers and hardware in the loop tests. We are convinced we can do it. We know we can go to an asteroid. That's no issue whatsoever. So this is just the right level of complexity to have some interest. But it's also up to you. Talk to the colleagues, talk to your professors, talk to the dean of the university, and tell them that this is something which is interesting. Normally don't use the argument that I say we need to do this to save our planet, because if you do a real cost-benefit scenario, there are indeed other things where it's probably better to put a lot of money. To me, the key is that the industry is interested in doing this, and that's why we should do it. Yeah? But okay, this is something for a discussion where maybe not everybody agrees. I'm drifting off. So let me summarize. Whom do you call? Right now, call me. That's me. That's my colleague Gerhard. Here we're just inspecting our new servers in the coordination center. And my telephone number is right here. Use your normal cell phone or something. And I summarize, I think Emily Latkavala posted this thing on how to give presentations. And she said, in the last few graphs, summarize what you said and pretend it's a tweet. So you're limited to X characters. Now I forgot what X is, so I may be too long here. But my summary of this talk is, in the last few years, the international community has made large steps forward in being prepared to respond to potential asteroid impact threats. And I hope you agree to that. And we now have the mechanisms in place. We just need to actually do the work. And like I say, I was really ESA-centric here. There's a lot of other work happening, as we will hear tomorrow, in Europe, but also, of course, in particular in the US, but also Japan is doing great work. They will go to an asteroid and return under the sample with Hayabusa 2. So this is really a truly international endeavor. So keep that in mind when you spread the news about what you heard here. Thank you very much.